So we're delighted that for our keynote presentation today, we can welcome Dr. Bruce Ling with the Stanford University School of Medicine. He is an assistant professor of research in the translational medicine program in the School of Medicine. He has an MA and a PhD from UCLA, and his undergraduate work was at Fudan University in Shanghai. He began consulting with the biotech core in Lucile Packard Children's Hospital way back in 2006. And the next year became a staff scientist, a senior scientist in translational medicine. Within a few years, he was named principal investigator on some projects. He became a member of Stanford's BioX program, and he became an assistant professor in 2016. He has had a number of research awards, including the American Heart Association Award in, I think, 2014. He has been named a Stanford Spark Innovation Program Scholar for a number of years, and he has received several NIH grants about commercialization, STTR grants. This is the equivalent of an SBIR grant, but it's granted to a nonprofit institution. His work involved looking at various kinds of omics, whether it's protein or whether it's DNA or RNA, and seeing what kind of things you can see in sort of a public health view in regard to molecular diagnostics and predictive analytics. So I think I should turn over the floor to Dr. Ling. Bruce, thank you very much for coming today. The floor is yours.
Yeah, it's easy to end the talk because I can easily get excited. There's a lot of things to talk about it, and working with a lot of very gifted colleagues, it's really great. So actually, Dr. Dasher's is a very great introduction for me. Actually, talking about a lot of uncertainties. So actually, I put this paper there. Actually, I just created this last minute. So this is for the Arius. There's an essay written by him. He's one of the AI leaders and AI CEO, Machines of Loving Grace. There's a lot of questions, Dr. Dasher gracefully talked about, and he has his own perspective, let me put it this way. And I really enjoy reading this essay. So if you're really interested in AI, you should read it. And how about this as the homework for this class? Okay, great. Okay. So talking about AI, actually, as Dr. Dasher said, the field goes by very quickly. Last year we talked about agents, and this year people are talking about the AGIs already. So I think this is a very simple slide, actually, from the so-called narrow AI to the AGI to the ASI. So actually, if you're not familiar with AI, you just think about AGI, and a lot of people talking about it. A lot of people interpret it in different kind of perspective. For me, AGI is coming. It's going to revolutionize the entire the society. A lot of things we're fighting today, trade war, the tariff war, but maybe in 10 years or in 20 years, I think it's a very short window in history. It will look like when you come to Stanford University, you're kind of regretting, like in elementary school, you got a D, that kind of feelings. So those things actually will pass. I think but what is really AGI? AGI means the machine is as smart, the intelligence is as smart as a human. It's not a surpass human. But then after that would accelerate the entire kind of intelligence, because if the machine is as smart as human, but it overcome a lot of the shortcomings, then it's going to iterate it very fast. Then what will leave for the humans? So that will be a big question. So that that essay, they talk a little bit about that. A lot of people think about the upside, but also we need to think about the downside. And but this time is It's like, I grew up in Shanghai, one of the largest city in Asia. And, essentially I went through the entire industrialization because, when I was in my childhood, there's no highway there, not a single highway in Shanghai. But now over there, it's like the density, it's very different today. And if I go back, my hometown now, it's not the old hometown I grew up. So it's very different. And then actually, think about it that, before you have the machines for industrialization, the steam machine, right? The first, the locomotive is definitely slower than a horse. The horse will never evolve. Okay, it's the same kind of feelings. And then actually you come from the computer. So if I mention the so-called Honeywell, I'm not sure whether you know the brand, it's about air conditioning, right? That's actually the first mainframe I used when I was in high school, because in my school was actually university. So, if you go to the Gates building there in the computer science, luckily I've done computer science there, and myself, you see there's a lot of ancient computers. I used almost everyone. So it's kind of lucky to witness the history. But I'm telling you, I really want to emphasize, this time the AGI is real. Okay, it's something that it's going to change everything. So you really need to think about how to, there's a lot of things you need to think about. For example, how do we educate our kids? When my kids apply for college, what kind of major should they study? And it's kind of very interesting. Also talking about the entrepreneurship, I have a little bit disagreement with Dr. Dasher talking about the ownership of those kind of opportunities by the big companies. Okay, so basically OpenAI dominates a lot of things. Okay, but there is the DeepSeek moment. People use a much less kind of budget and can do interesting things. And as Bill Gates said, he's not worried about the big company. He worried about those companies in the Silicon Valley garage. And there's a very interesting garage. If you're not familiar with Palo Alto, that's the HP garage. I think it's next to the elementary school there. I used to send my kids to elementary school every day. I passed that. It makes me think. Who remembers HP? HP actually doesn't exist here on this land anymore. They have to move to Texas. They used to be on Richmond, very big. Okay, so the AGI means the machines as smart as us. Then post AGI, it's called ASI. So I don't even want to think about it. Okay, that's really beyond, but it's coming. Okay, it's like 5 years. I would say 5 to 20 years. Okay, exactly how long I don't know, but it's about 5 to 20 years. And after that, a lot of things will be changed. Okay. So this basically is the history. I stole from some of the internet screenshots. So if you look at it here, the word artificial intelligence is about in 1956. It's about the same time as a molecular biologist. The DNA was discovered in 1953. So it's about a similar time. And then, just ignore everything in between. It goes to the GPT-3 2020, and then go to the GPT-B 2024. It's only like 4 years. But these 4 years, things will change. Very soon, this intelligence is going to operate the physical kind of tools. Okay, so the agent is going to operate a lot of they can do the internet browsing, they can write your code. Okay, so I still write some code, but I have to admit 70% of our code was written by the Gemini. It's very effective. Okay, so this actually is a very important slide. Okay, so if you look at it here, if you think about the parameters, people are always talking about the parameters. Okay, parameter is very important. Okay, so how many parameters? Scale. This time, scale determines how effective the intelligence would be. Because from the 2018, the GPT-1, actually that's shortly after the famous paper. I think my colleague Odawa is going to talk about it. Attention is all you need. That paper, and it goes to the first, the GPT-4, you see how many zeros, from a million to trillion. So how many zeros? And then actually from GPT-4 to 100 trillion. This line is very important. That's the red line, 100 trillion. 100 trillion basically is how many neurons in your connections in your brain as a human. Okay, so if the machine is reaching that step, it's not that far away. It's like 50-fold. But from 2018 to the GPT-3 is about how many years? It's about like 3 years. It's about how many zeros fold of the evolutions. So when the line is here, the society is going to be changed significantly. Actually, it helped me answer one of my childhood kind of question. I always have an unsolved question in my mind: where is the aliens? Because you never see an alien, right? And I assume if if the Earth is not the only thing in the world, in the universe, there must be a lot of aliens. Why you don't see them? Because maybe they already passed this red line. You don't really need a human body for it. Actually, human body is not effective at all. You talk about the communications. Let's say if we connect a line between me and Dr. Dash, it will be much more effective than I talk to him. So in a second, you can transit the billions of bits, right? So actually, that's really interesting. Maybe really the alien is somewhere in the air somewhere. It could be a cloud. It could be when someone tried to do the mission around me, try to convert me to some religion. They said, look at I really like what his analogy. Look at the water, but the steam is also water. The ice is also water. They're very different, but they're the same thing. It could be like where I have the hemoglobin in my blood, but somewhere in the air, somewhere could be a lightning. That's the life. You just don't know. I would just. That's actually the AGI kind of the impact could be. So I think the society is kind of lagged behind. You see like a lot of the leaders talk about the risk. I think if it's going to come, it's going to come. Okay. And when I forgot who said that, in the future, maybe the AGI or the ASI will look at us. It's like we look at the ant in the garden. You don't care, okay? And also, it's a bit difficult to talk to it because like in the ancient Chinese philosophy, they're talking about you can't talk into some kind of worm in the summer about the winter because in the fall they die. They never know the existence of winter. So that's actually, talk about the philosophy, a lot of philosophy start to make sense. Anyway, so this is actually very important. That's why, this gap of 50-fold kind of the difference of the intelligence, I think it's going to be achieved very soon. 5 years, that will be fast. 20 years would be a little bit slow, but not a half a century. Okay, at least I hope I will exercise every day. I want to see it. I'm sure Ozawa will see it. Chicago will see it. But if you witness that, there's a lot of responsibilities. There are a lot of how can you help? Okay, so actually the machine is already much better than us in a lot of areas. Okay, we talk about the code generation. Talk about actually a lot of the teachers are battling with the AI, the homeworks. My son actually came back from college. He told me that everyone is subscribed to Cloud AI for their homework. If you don't subscribe, you are going to be disadvantaged. But you need to de-AI it. To submit the homework to Dr. Dasher so that he will not fail you. So it's kind of very interesting that think about that one. It's also that across the street there's a very good high school called Palo Alto High. You start to see people graduate from there, go straight to the company to work now. Some of those kids, I always tell my friends' kids, that don't listen to Zuckerberg, drop out of Harvard in second year, or Bill Gates dropped out. Because they already coded for 6 years, according to the ladder in the software engineering. They are senior software engineers already. So you can't really compare because you just started, okay? So why all of a sudden things changed? Okay, actually there are two things. It's important. One is mathematically, it's always there. There's the information theory. Okay, I try to teach to my students about the information theory. So what is the Shannon? So there's a very good book about that well-known scientist about the Shannon. Okay, and the information theory. Basically, he said that the information can be coded using the Boolean algebra. and can transmit to you without understanding of the information. Just that. That's my understanding of the information theory. So basically, why Boolean? Boolean is 0, 1. Why Boolean is so important? Because of the semiconductor. Semiconductor is 0, 1. So if you link all this, everything starts to make sense, you know. And also that all those 0, 1s, why suddenly become intelligence? Because of this paper, okay? They start to understand the meaning, you know, for example, translation. So nowadays, if you want to translate English to French, whatever Southeast Asian country languages, it's trivial, okay? And also that this famous guy, and you know, the GPU, you know, they used to be a company, you know, in the Silicon Valley, had very little attention. Actually, I have to thank the Japanese. So in their history, almost collapsed. I think I forgot which company. So they did it wrong, and then you know, Mr. Huang went to the company and then confessed they did it wrong, and the Japanese gave them the second chance, and then redo the project. So you know, without the Japanese, our Silicon Valley hero would not even existing today. So anyway, that's a separate story. So basically, combine the hardware. This is the software combined. Then you see the explosion of the AI revolution. So you know, I want to use an analogy because to explain that it will be very simple. Think about this as a God. Now, in the paradise, that multidimensional space, he understands everything. So everything, think about that. There's a concept, there's a coordinate there. Okay, only God knows. Okay, so if you know that the coordinate, you know where, you know, you decode the meaning. Okay, so in that multidimensional space, it will be very high dimensional. Okay, so think about the language. So whenever you think about the dog, okay, you know, I think about it. It's very interesting. This also goes back to my high school when I started to learn English and learn Japanese at the same time. And you know, I have to apologize. My Japanese colleagues, my Japanese already returned back to my teachers. So basically, the dog barking, different languages use the different word. In the United States, we call that woof woof, right? In Chinese, wang wang. In Japanese, I don't know how it was called, but yes, wang wang too. Okay, so basically, you know, you go to French, there's a different. But your brain, when you think about the dog, forget about that DOG or however you write that. There's a dog image. There's a coordinate in the paradise there. If you find that coordinate, then go to Japanese or go to Chinese, go to French, it's just an encoding, decoding issue. And this encoding, decoding is by the so-called transformer. That so-called attention is all you need. Actually, it's pretty simple. It's very straightforward. Okay, so then you need a large data set. Okay, if you read that essay, actually, I showed you by the Dario. So you really need a lot of data set. Okay, text. You think about the text, image, speech, structured data, 3D signal. You think about that a dog. Doesn't matter if you see a picture or see that DOG, you close your eyes, there's a dog. Right? You know why? Because when I think about dog, when Dr. Dasher think about dog, or whoever, we all think similarly. There's an image in your brain, or however vague that is. Because you know what? Because we're called humanity. We're all humans. Okay? But if you talk about plants about a dog, you know, I don't know. The coordinate is where it needs some additional research. But if we are all human, they reside in the same place. If you can decode that, things is easy. It's the same kind of thing here. So it's the text, image, speech, structured data. So you go through this foundation model adaptations, you can do all sorts of these questions around this dog concept because you know the coordinate there. Okay? So basically, this is the thing. So if you have the dog there, so let's say this is the multi-dimensional space. It doesn't matter it's a video or it's a text, the dog are all in the same green area. Okay? So if you understand this, it's very simple. So so-called text to video, video to text, you know, why all these magic things suddenly start to work? You know, conceptually, it's pretty straightforward once you understand it. And the rest of it, you can, now you have the agent to do it now. Okay, so basically you encode the data and decode the data. This is the sort of the latent space. Only God knows. Actually, a lot of the times, actually, we don't really understand why it works. And I show you one example that people did it. I'm going to introduce maybe a little bit later. So basically that you get a solution, but you might not understand what's inside this black box. Because in the black box, you just have a bunch of neurons. Okay, so this is the current architecture. So this is another thing is very interesting. So basically, if you have the text, if you have the video, okay, if they are talking about the same thing, you can think about it, you can relate them. The diagonal line should be infinitely small because they're talking about the same things. It should be 0, right? So this is the so-called clip technology. Again, it's old now. It's 2 years ago. But last year when I talked about it, it's very new. We're working on that. We're very excited. But now this year, like Dasha said, oh, it's so old already. So you can think about how AI evolves very quickly. So you think about this is in the medical field. Whenever you go to see a doctor, he gives you a report, right? This report is your annotation of your disease, your condition, right? If you have a CT, you already annotated. These two already kind of correlated. So once, let's say you have this model, if I give you a CT result, you should give your condition, right? Or vice versa, right? So in this way, this has solved one of the biggest problem in the image analytics in the history, because you need to label, this is a dog, dog jump, dog sleep, these are all dogs, you need to label it. But in the medicine, think about it, because I'm a medical researcher, in the medicine, people already annotated your medical record. If you have millions, tens of millions of medical record, a lot of things can be done very quickly, with a lot of information can be decoded. By the way, if you have any question, you can stop. And no, so if you have these things, the so-called vector database, I don't want to, embarrass a lot of my colleagues or students who already, like me, returned my Japanese learning back to my teachers. So a vector basically it is a point to a coordinate in the multidimensional space. So the vector database become very hot, and a lot of people developing tools. Okay, and one of the tools is, I just want to say that, for example, the so-called Llama index tree. Actually, it's developed by a San Francisco boy, which is, I think, he's very young, less than 30 years old. Okay, so now it comes to a time. There's a lot of opportunities. Okay, don't worry about the big companies. They can dominate something, but they cannot dominate all the time. That's my encouragement to my colleagues and to my younger colleagues in particular. So, you have the large language models. You can build all these things together. You can take the data, you can find the coordinates. So now you build that multidimensional coordinate space, you can do a lot of things. Okay, so I try to be quick. Oh, I moved this slide here. Initially, this is at the beginning of the slide because I try to make sure that this is my lab's doing. So basically, we go, so we do the multi-omics platform. So we just acquired a machine from Thermo Fisher, like $1 million for the multi-omics. And we're going to build the facility, and we're going to build a production. Every baby and the mom in the Lucy Harris Children's Hospital will be phenotyped. And then also we have the images data, and we have the video data. We try to develop a novel diagnosis, and also we have electronic magic record. And this, 2 o'clock, I put this icon there, the wearables. I put the wearables there as well. So, I talk about EMR data. So my colleague, Ozawa-san is going to talk about that. So basically, there are 2 kind of models. One is the regression model. Can you use in the clinical history, use in the large language format, and try to decode either classification of what kind of disease you have, or we recreated or kind of the generative AI to recreate your clinical record in the future. So this is the digital twin. So we construct a digital twin for you in a computer and try to synchronize with you. For example, next January, next February, what kind of things going to happen to you? Okay, so I'm going to skip all these things, and the BERT and the BART and all those things are developed by different companies. So now with these neural network models, you can do all the parallel computing. Initially, during the machine learning time, statistical learning time, we can only do do you have this disease or you don't have this disease? Now we can do hundreds of disease predictions simultaneously in parallel. So the GPU actually is That's why everybody wants to buy GPUs. There's a reason there. Okay, so I'm going to skip all those. I will leave my colleagues Ozawa-san to talk about that, talk about the digital twins. Then another thing I want to talk about is the wearable data. So you don't go to hospital all the time, right? So it's the discrete data, using discrete mathematics. So you want to continuous data that monitor you, but you want to be non-invasive. So wearable data, like an Apple Watch or smartwatch, would be a good one. So I just want to try to, because a lot of people, they don't know this, actually. This kind of technology exists. For example, I deliberately covered the Apple logo here. I think it's not fair to other smartwatch vendors. Because, for example, like in the morning, we're talking to like Sony. They have a smartwatch brand themselves. So we're talking about collaborations. So the smartwatch can generate a lot of different kind of data, like a PPG data, like a sensor of the, you can simulate the heart rate variabilities and oxygen saturations. By the way, in the United States, unfortunately, Apple lost the patent war, so you don't have the oxygen capability anymore. But I look at my colleague Ozawa's watch. It works on his watch. He's a Japanese, he bought it from Japan. So it's kind of interesting. You see these kind of regulations about the technology, which is ridiculous to me, but that's life. So we talk about the so-called bloodless blood test. So what's called bloodless blood test? Don't confuse it with CGM, continuous glucose monitoring. So they put a patch. That's still invasive. Talking about totally non-invasive. So basically, from your watch, you get the sensor information, and then to simulate your bloodstream, what kind of glucose, what kind of potassium, what kind of NT-proBNP, so on and so forth. And it sounds like the scientific fiction, but for example, potassium analysis is they already got the FDA approval already. So it's as good as a blood test. And others, people are working on that. And yeah, for example, this is another one that actually, this is not from my group or from one of my colleagues' work. So basically, they're using the gyro kind of movement and the sleeping pattern activity versus the sleeping pattern. For the pregnant woman, they can decode where you are, how many months of pregnancy you are. Okay. So if you ask me, if you read this paper, we reproduce their work. If you ask me why it works, I don't think anybody knows. Okay, so basically that again, you see all these neural network, people get get used to it already. But if it is accelerated, that means you are going to be preterm maturity. Okay, so there's a lot of things you can do with these wearable signals. And last week I was in New York City. We were talking about the behavioral health, for the high school kids and the high school graduates. One of the things I was totally shocked. I think the Gates Foundation maybe will fund this study with the Healthix, which is the largest health information exchange in the United States. So the highest rate of the lung transplant for young people. Do you know where? It's in the heart of New York City. Can you believe it? We are a developing nation. I thought we are a developed nation. I thought it should be in Africa. Or maybe Africa cannot afford the lung transplant. So they vapor, they smoke, they do all sorts of things. But think about it, if your behavior changes, this sensor information will sense it. If you can build a model, hopefully you can help. There are a lot of things you can do. So a lot of areas. So, this is another one. So for example, that's why when Dr. Dasher said that, big company, they dominate. So I think there's still rooms. There's a lot of rooms. Okay, for example, this one. I just learned this for the past about 2 months. One of my mentor, Gary Dunstad, he led me into this field. So the Mr. Vitason. What's the Mr. Vitason? So how many women in the audience? About half, right? So I thought I know women. I married since college. I married pretty early, and I had 3 kids. I thought I know women. But after I learned this, I know nothing about it. So basically the menstruation. So basically, in 1919, did a comparison, the women about 40, they only total have 40 menstruations. Because they start to have babies, they need to feed. And then during that time, menstruation stopped. But now, because women they are as equal as the man now in the society, performing all sorts of kind of the responsibilities. And I foresee that in the future, it's every country, the PhDs, woman is already exceeding the man. Okay, so this is politically incorrect. Okay, don't follow my behavior. Whenever I got my voting, I always look at a woman first. Pick that. If I don't, most likely I don't know any of the candidates, but I need to vote to show a dry pass. But the thing is that the menstruation is that now we have about 400 menstruation. Okay, a lot of women actually they even get their egg kind of freeze there for future kind of pregnancy. But for this one, do you know any of the men in this audience, 1 out of the 3rd woman at the reproductive age, they have the heavy menstrual bleeding? Do you know? Do we know? I'm sure you don't know. I don't know. I feel it's a shame, to be honest. That's why UK, they actually have around $50 million. Okay, whenever we see that kind of large number, our eyes kind of. So we go to Dr. Gary Dumpster. We quickly assemble a team, from the Oxford, from Netherlands, UK, United States. We assemble a team to apply for that. So we propose a couple of the technologies. So it's like Dr. Dave Stevenson talking about pregnancy. We don't really understand pregnancy. Do you think you do, but we don't. When my wife is pregnant, is the baby big is good? Small is bad? Actually, I don't know, honestly. So that's why when Stevenson wrote that paper for the Prematurity Center, that's basically with every researcher's name on that paper, basically say, we don't really understand the disorder because we don't understand even the normality of the pregnancy. It's the same thing here. Do we understand the normal menstruation and the menstrual cycle? What happened? Okay, so it's a little bit biology. Only Homo, the species, they have the menstruation and also the beta they have. Why? Nobody knows. So how can we help? Okay, so we propose actually, for example, wearable. We propose a dry blood card in the pad to sample. And we propose try to understand, build some kind of mechanistic, the patterns. Because the menstruation cycle, they have a cycle. If you violate this cycle, the woman is not happy physically. Okay, so there's a lot of things you can do over there. So that's why I said, the AI is a lot of things. But by the end of the day, you need the data. So I call that 4 AM learning. One is called multi-center, multi-modality, multi-task, and multi-organ. Okay, because the multi-center is easy to understand because an Asian population versus a Caucasian population would be totally different. For example, when the Wellcome Leap, the UK they issued that funding, they deliberately say you have to validate across region, across ethnicity. So that's why I assemble Asian population, assemble Caucasian population, and African population. Okay, and the multi-modality, because that the blood test sometimes is one kind of thing. So you can get a different kind of data set, and the multi-task. So basically, it's not only one condition. It's a different kind of conditions, and also that most likely not only affect one organ, could affect different kind of organs. Okay, so again, I go through this one. We talk about I can skip that. There's a lot of those kind of image data, a lot of the video data. Can you decode that together with record? Okay, so basically that across the pregnancy, this is one of my major research under this leadership that, all these problems, we just go one after the other. So Dr. Stevenson just retreated from the dean of the medical center. He said, his last mission is to conquer the prematurity. So, well, if one of our father wants to do it, we have to all participate to help him. Okay, so the key one is that how do we devise personalized medicine? Even everyone is different. In the medical field, there's a very good word called the endotype. We try to separate people into different kind of subgroups because a different age group and different kind of ethnicity, they might behave differently towards therapeutics, towards interventions. Okay, so if you can separate them, then you can the so-called personalized medicine. So then actually I want to talk about our collaboration with Nippon Life. I really want to thank my Nippon Life colleagues, okay, and thank Dr. Desha. Dr. Desha helped me tremendously. to maintain the relationship and also help enroll the visiting scholars from the Japan. And now I think I hope they're happy. You'll see, they will present their work. Okay, so one of the things that Nippon Life actually is a very interesting company. And so this actually is their slide, and I stole from there. That's why I put their logo there. So basically, they want to become an AI company. They are not as they have a long history. Their leaders actually joked about that, but they are very innovative. They want to send the young colleagues, very capable colleagues, to Stanford, so that they can disrupt themselves, transition themselves into it's called an AI. Usually, when I present, I call it AI plus data, or they say AI cross data. Okay, they want to amplify the AI capabilities. And one of the things is that we want to do how do we predict the disease risk? Okay, because this has something to do with the insurance policies. So if you look at these things, the key one is that if you can build a signature, multimodality signature, you can stratify the patients into subjects into different kind of patterns. Then can you build all these baseline, disease baseline, population baseline, personalized baseline? Because, for example, in certain kind of condition, this subject could be called disease. On your physiology could be it's just an annoyance. Okay, so this the thing that simple the classification of the disease is good disease. That's the traditional physician kind of perspective. But in the future, it will be data driven, and I'm sure that the AI doctors will be much better than the doctors in the future. Okay, and so that will significantly shape the ND education in the United States. For example, we're working on something called AI nurse. In the United States, the nurse costs about $90 per hour. Okay, but she's like a mom when she visits the doctor, she wants to talk to that doctor forever. I always say, Mom, the doctor is busy. We need to go. Okay, it's the same kind of thing. But if the AI nurse is only 90 cents per hour, okay, you can any kind of accent you want. Okay, he or she can talk to your mom, an ending. Okay, so that's the power of the technology. It's going to improve your life. Okay, so for example, I was in New York City last week. We talked a very simple use case, colonoscopy screening. So the nurse told the subject, you get the colonoscopy screening. I'm not sure because some of the audiences, they're very young. I got caught up, when I was like 45 years old, I was always ignoring this kind of ignoring. I don't want to do it. And I don't want to say no either, I just ignore it. And someone needs to call you. But every time they call you, it costs money. Okay? And so the first question, did you get the screen, colonoscopy? If you get, where did you get? Then the third question is that, did there follow-up? 3 questions. Okay? So the AI nurse can certainly do that. The other field is called customer support. Okay? So anyways. So I think, by the end of the day, if you talk about enterprise, talk about entrepreneur, it's all about this formula in healthcare. It's about value. So in the United States, we call it value-based care, right? You want to use less money to do more. Okay. I think the insurance company these days, the United States, the insurance companies, they are on the wrong track. Whenever I look at my insurance bills, it's very high. So something needs to disrupt these kind of patterns, practice. So basically, you need to provide a better quality, more service at a lower cost. This is called value. That's how we can compete. And we can compete. It's just like you're auditing your finance. Okay. So, these days, the data is collection is not a problem anymore. And then actually, how we can utilize data, how we can benefit society. I remember that there's a movie, the Jurassic Park. I'm not sure whether you still. It's kind of an old school movie. So if you're not familiar with the story, I just recap that a little bit. Basically, whatever the dinosaur, they are all female. So even if they fled out of the farm in Hawaii, they cannot breed. But in the end, the characters come out. They see a couple of very friendly dinosaurs laying eggs, and the eggs is small dinosaurs. And they say nature will find its own way. I still remember that. And I think nature will find its own way when the AGI comes. Thank you.
So, Dr. Ling, let's think about one question and move on.
So, very fascinating presentation. But if I really look at the beginning of your talk, are you saying that this is going to be a huge level event, AI for humanity? I think a thing. And the second thing is, I feel very strongly written on it, that this AI is really causing what we call as the rise of the bonobos. And when I say rise of the bonobos, the species sitting here is actually going to dumb down so much over a period of time that we will not really do anything but just.
Yes, actually, I think, if, I didn't give too much the thoughts about that, but, if you go to this article, machines of living grace, and he actually addressed that a lot of the questions in that article. I really like this article. It's not that long, but it's a fascinating article, and it's by Dario Modi, the Anthropic CEO. But I can answer that question that I think in 100 years, things are going to be very different, for sure. This 100 years could be 20 years. 20 years maybe a little bit much. So I can, at least for my lifespan, of course I need to exercise every day. I can see some of it, the prelude of that. Okay, because if you parachute into the Amazon, you look at those people in the jungles. So that actually is how the future is going to look at the species in the audience, which could be a sad moment. Okay.
Yes.
Yeah, but that, where are we in the real area? That's called reality. Sometimes it's life.
Thank you very much, Doctor.